Hey everybody, this is Larry. This is June 23rd, or the day 23 of the Leetcode Daily Challenge. June Challenge, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So today, before we start, I want to talk about a couple of things, right? One is, it's very hot here in New York. This is a little bit of a vlog situation, as people who watch me maybe every day might know. So that's a little bit big, but that's what. Never mind. But yeah, and I just came back from running 7 miles, so I don't know, whatever. But just to kind of give you an update on that one. But I think so. One thing that I would say is that I think we talk about rating a lot, just because I don't know. I mean, this is a Leetcode focused channel, and we do a lot of contests together. And if you kind of look at my recent performance, ever since I was 3,000, you can see that I have not been doing well. A couple of these things, to be honest, I maybe blame Leetcode in terms of like I think this one, maybe it was that one. I don't. Oh no, not that one. One of these, for example, there was just like Leetcode servers having issues, and another one, I don't know. And actually, I don't know what's up with this one. How am I 800 on getting Q4? Oh, this one, huh? 800 really? How did people get it so quickly? Oh, that's the one that people sometimes YOLO'd and got it. Oh no, that's the sliding window one that I was a little bit bad at. Okay. But and 3 out of 4. Which one is the Q4? Oh, this is the Q4 that that a lot of people got just from Oh, this is the segment tree Q4. Okay, yeah. And then apparently apparently Googleables a lot of people got. So I don't know. I mean, the reason why I want to bring this up is that wow, there's also a lot of, well, this one I think this was a 7 wrong answers. But I think the reason why I brought it up here, I have a point, I promise. But the reason why I brought it up here is just that, and this one, which is this morning, for me is this morning, I also got like a negative 20. So it's been a very poor streak, as you can tell. I'm down like 200 rating points in one page, and only this one, which is, reasonably okay. But my point is this, right? If my self-worth is determined by my rating, then I'll be very sad. But on the other hand, it's not, right? I am trying to do training right now for running, as some of you know. Also, what is going on here? Why are there 2 Yon Shans? This Leetcode thing will always be forever buggy. But in any case, my point is that, yeah. So I'm doing a lot of running right now, which if you watch enough, you'll hear about it from time to time, for good and for worse. But the point is that if I would go out for a race, for a marathon or whatever, there are also a lot of things out of my control, right? Like, it could be very hot. It could be, maybe it's a hilly situation. So that means, like, obviously if you go faster on a flat surface versus going slower on a hill thing, it doesn't mean you got slower, right? But in either case, the thing that determines how fit you are, or whatever, at the end of the day, is not your race time. It is the training that you put in, right? And it is the same thing, kind of similar, maybe not quite the same for some reasons that I'm not going to dig into, right? Is that, yeah, my rating will go up and it'll go down because I don't know, I'm just having a really rough stretch for some reason. Some of it I think is because maybe I am actually running too much and my mind is just not, I don't know, into the right place. I mean, look at all these wrong answers. I mean, I think the wrong answers bugs me more than the rankings, because if you look at if you look at when I was doing well, I don't get wrong answers, right? So I think that's the biggest thing. I don't know about this one, but you see that when I do well, I usually don't get wrong answers, but so it is, and a lot of the wrong answers are kind of just sloppiness, right? I call it sloppiness, but if I knew I'm being sloppy, I would just, take care of it. So I don't know. It is something that maybe I need to be mindful about. But my point is that it does not. The rating does not determine who I am. So I don't care that much about it. Right? I am very well trained per se. Maybe I could practice a little bit more if I really, really cared about it. But at the end of the day, rating is just a number. Remember what you're training for. You're not training to be better at a number. You're training to be better in hopes that maybe your rating will reflect how much better you've gotten over time, right? Over any periods of time. So that means that, and another way to think about it is that if I'm actually good, it doesn't matter whether, maybe maybe I'm having a rough patch, and maybe that rough patch will last for a couple months or whatever. And actually it has, I suppose. This is already April. This is already June, right? But, your rough patch will last a couple of months, but it doesn't matter because I know that I'm still pretty good. So it doesn't bother me that my rating goes down or stuff like this. And, sometimes maybe I'm lucky. Maybe I'm, unlucky. It doesn't matter, right? Because I know how good I am. And the thing is that over time, of course, you have to adjust, right? Like, maybe if it's long enough, maybe I have lost a few steps, but that's also okay because I don't need to be better at this anyway. My point, though, is still that if you focus on improving yourself, your rating will eventually converge to where you will be. And so, like, having one contest going up a lot, I mean, obviously you should celebrate and enjoy it, but in the same way, if you have a really rough contest, you should not beat yourself, Like, if your skill is there, it'll come back up very quickly. So I think that's my kind of point and takeaway. Because I think one thing that, there are a couple of things that are telling, right? People might not necessarily, I mean, you may, watch this video, listen to this video, and you're like, oh, yeah, of course, this makes sense. Hopefully, anyway. If you disagree, then, I don't know what to say. But yeah, you're like, oh, of course, this makes sense, this agrees. But then you still find yourself doing things that betrays the fact that you you care too much about your rating, right? Yeah, like I think a common one that I always complain about, or I don't complain about, but I guess it is a complaint, I don't know. But I complain about other people complaining is a contest being rated or not rated. And in that sense, if you really think about the situation, then it doesn't matter whether a contest is rated or not. What you got out of the contest is training, right? Hopefully. And if you got that training out of the way, then it doesn't matter if your contest, the contest is rated or not, or if you did well or not. And of course, if you did well and it turned out to be unrated, maybe that you didn't really do that well. It's just that server treats some people, in a non-equal kind of way, right? Then in that case, did you actually do well, or did just other people didn't do well because the server was having issues, right? So that's kind of a couple of things to say, right? And then the other thing that people do that I always complain about, I don't really care that much about it, to be honest, but for certain people, it's just that, like, I want them to be better long term, right? And the rating is just a snapshot in time, and then people do things like they submit all the problems at the same time, and then don't do the contest if they read the problem and Q4 is too hard or something, right? That's just like, at the end of the day, if your rating only represents things that you can solve, then your rating is not your rating, and also you're not really that good. And then the other part of it is like people using alt accounts and stuff like that, right? Like, I don't know. So, okay, so in that sense, what do you care about training for, right? Like, what are you training for? I think that's for you to figure out. And at the end of the day, you have to figure that out. If you're training for an interview, for example, then do everything you can to be good at the interview. Everything else, like the rating, use it as an indicator. In fact, that's the problem, right? Is that if you want to use your rating as some sort of readiness, like as a unbiased way to determine whether you're ready for interviews, maybe that's a good idea, maybe that's not. I'm not quite sure on that one. But like in that case, then if you're doing all these weird things to, optimize for your rating, then it's like, are you lying to yourself, or are you, Like no one cares about your rating on an interview. You know, it's either you do well in an interview or you don't. I think that's the thing to say. And there are definitely people, and maybe this is me when I was younger as well. Is that I think, people look at rating and they think that's who they are, and I think that's a very not a healthy mindset. I think you enjoy more if you like just if you get to a place where you can enjoy doing these things, then that'll be important. That said, I mean, once in a while it's okay, but like, you have to be honest with yourself, and if you cannot be honest with yourself, then you cannot really figure out ways to grow. And being honest with yourself includes having your rating hopefully fully captures who you are as a coder, right? And not just here's my best 5 contests, and I only submit all of them if I finish first, kind of, I don't know, or something like that. Then it's just like, well, yeah, what does your rating tell anybody? I don't know. All right, that was a long 11-minute intro. I probably could keep going, but hopefully you get the point. Let's take a look at today's problem. 1438, longest continue. Oh yeah, let me make the final point. My point in showing that is that, sometimes I struggle too. Like I go through stretches where, as you saw, it does not go well. So, I mean, it's okay. It doesn't really, no one's going to be like, oh, Larry, you're an idiot now. Okay, maybe some people, but nonetheless, no, not seriously in the way that I care about. Okay, let's actually get started. My apologies if, but hopefully you realize that and you skip ahead if you didn't care to listen to it. But all right, let's take a look. 1438, longest continuous subarray with absolute diff less than or equal to limit. Given an array of integers nums and integer limit, return the size of the longest non-empty subarray such that the absolute difference between any two elements in the subarray is less than or equal to limit. Okay, so I mean, this is going to be the same idea that we kind of talked about the last couple of days. So definitely, if you haven't solved the last couple of days daily problem, go back to it and or at least go watch the videos and have an idea. And the idea that I think about is just the contribution, right? This idea, I mean, yeah, you could call it sliding windows as well, but the way that I think about it is just through contribution. And this contribution, what I mean by that is that for each index, where this index is the right boundary or like the rightmost index of the subarray, what is its possible contribution to the answer, right? And I think I like thinking about this one because it allows you to kind of get more into loop invariance. Okay, and for example, for this problem, and I don't really have an answer off my head yet, just to be clear, but it just has that feel for me. Right, so maybe if I'm wrong, then I'll be like, oh, just kidding. But yeah, so you have something like this, and limit is equal to 4, right? And this is how I would play around with in the contest, at least in my mind. Again, I haven't really thought about this yet. The idea here is the invariant as you grow a window, right? I think an observation about this invariant, about sliding windows for this problem is this, right? Is that, let's say, I don't know whatever it is. I just heard lightning outside, or I guess I heard thunder. Lightning, you don't see it. So, I don't know. Luckily, I just got back in time. But anyway, for this particular problem, let's say you have A, B, C, D, or whatever, right? I missed the C. So for this, let's just say the initial window is going to be A and B, and now you're adding in C as the sliding window, right? The thing is that, so for this one, you're trying to find that absolute difference between any two elements in this subarray is less than limit. So the observation about this particular problem is that when you add in C, let's actually add a couple more things. I think maybe just having two elements doesn't show enough. So let's say we're adding Y, right? So here, it is what I want to say is that it is sufficient to check Y versus A, B, C, and D, because we don't have to we don't have to recheck D and C, D and B, and so forth, because the invariant is that it doesn't change, right? That is part of the invariant, is that when we previously checked D for C and stuff like this for the limit, it doesn't change when we add Y in this particular problem. So that is sufficient to check Y against these things, right? Okay. And then another thing to realize is that, so that's the key observation about sliding window, is that you don't need to check all the pairwise things, so that makes it cheaper. And then another thing to, the next step from that observation is that it is sufficient to keep track of the max and the min, and then when checking the Y, because in a way, right, I hope that makes sense, is that, yeah, only the max or the min matters, because those are the two places that are possibly the farthest from Y, so that it would mix it so that you have to remove some elements. So okay, so those are the two observations that I noticed. Those are the observations, and then now we have to try to figure out, so let's just say that, right? And I think a lot of times people ask me like, oh, how is this a sliding window, or like how, sometimes they're like, oh, sliding window, or sometimes they're like, oh, how do you know that this is a mono queue problem, mono stack problem, whatever, right? And the thing is that, okay, this is how I would do it every step of the way, right? And what I mean by that is that, okay, I noticed this observation, I go, okay. Like, I mean, and to be honest, I'm explaining to you at home right now, and trying to go in a slow enough pace that people understand at home, of course. But let me get some water real quick. A little dehydrated. Why is everything weird? Sorry, hang on. Technical difficulties. Talked a lot, so. My point is, I want to just say that as someone who is very practiced and maybe a good programmer, or at least a good problem solver, I don't know, is that I make these observations in like maybe 1 second or 2 seconds, right? But it's just that and I'm not saying that to brag, but sometimes people ask me like, oh, how are you able to get it so quickly? How are you able to get it so quickly? And my point here is just to show you how I think about every step of the way. And these steps sometimes take a second or two, right? I'm not, like I said, I'm not trying to humble brag. I'm going to show you like, well, this is why it's possible. And some of this is that I've seen similar problems before, right? Like, I don't know this one, but, so the first thing is I go like, okay, I see it. And then very quickly after that, I noticed that, because we're talking about absolute differences for this particular problem, and we're trying to keep it less than or equal to a limit. So knowing that we basically have this, we're trying to figure out in a way, the max of absolute value of A minus E, B minus E, ... right? And the way, and some of this is practice, is that noticing that that is just also equal to max of I don't know, maybe A minus E, E minus A, or something like this. I forget how to write that precisely. But my point is that, I see it in my mind. And then here, then the next observation is that only checking min max is enough for adding Y, right? And then now I ask, okay, so then in my mind I go, okay, this is how I break down the problem, right? Is that if checking min max is enough, is there a data structure that lets me do it quickly? And the short answer is yes, right? In fact, so then now we have, we want a data structure that supports add removal in fast time, let's say over 1 or over log n, and allows us to get min-max queries, right? I think that's basically the idea, right? And then now we go, okay, we want this data structure because we have a question. Our question is, we want to check the min-max, and we want a data structure that allows to add and remove in very quick time. And of course, there are, well, two ones off my head. One is going to be the I say off my head and then I blank out. In Python, it's going to be sorted list or some sort of balanced binary search tree, right? And of course, if you're a little bit more attentive, you'll realize that you only add and remove at the beginning and the end. And as a result, you can also use mono queues, right? Or you only add at the end, you remove at the beginning and the end. Yeah. So that's going to be mono queues. Right. I'm not going to go over I'm not going to do mono queues for this problem, I think, just because I want to keep this video is already kind of long. So we'll just do this so that it's more obvious. So then now here again, the same structure is going to be what we talked about for all the other problems, right? So left is equal to 0 for right in range of n, and then now we also have a sorted list, right? Yeah, and then here we go, okay. I mean, there are a couple. This is just implementation details. You just have to do your invariants, right? Because basically, right now, I'm thinking of two ways of implementing it. One is add and then verified invariants, or the other, and then is it verified the right word? Ensure maybe. And the other, so this is one way, and then the other way is to ensure that when we add, the invariants are true. And of course, both these ways are fine. I just want to point it out because I think sometimes people, look at my. Well, you heard that thunder, so this time it's not just me. That was very close by, I guess. That was very loud. I didn't know what it was for a second. I thought it was like, I don't know. And I was like, oh yeah. So I got him just in time. But yeah, sorry, lost a little bit focus there. But yeah, the question, I just want to point it out because I think sometimes people look at my code and they go, oh, we must do it that way, it's the cleanest. But a lot of times, it's just a little bit of a choice. As long as you know what you're doing, that's fine. So here, I'm going to do both of them just for a second. We'll delete one of them. It doesn't really matter which one, but I think it doesn't matter for this particular case. But yeah, but then here, for example, if we want to do it the invariant way, we go sl.add, what's it called? Num sub right? And then now we can check to ensure the invariant part. We go, okay, while length of SL is greater than 0, which it always should be, unless limit is really, I think this should always be true. So, but I always write it in just for protection, but maybe that, maybe it should be an assert anyway. But yeah, then now we choose the smallest element, the biggest element. So then here, while this is greater than limit, then we want to remove num sub left, right? And this really weird looking loop will always eventually return true, just because if limit or if there's one element left, this is going to return 0, and this will always be false, right? Did I say return true? I meant false, right? And when there's one element left is going to be equal to right? So this is one way to do it. You add it and then you ensure the limit. The other is just to make sure that the invariants are true. So maybe you can write something like while I don't know, SL the biggest element minus the current element that we're going to add is greater than limit, or the smallest element, the absolute value, right, is greater than limit, then we just remove num sub left, right? And here we actually, I think we have to do length of SL is greater than 0, right? And then now after the end of this, then it should be good to add num sub right, right? So this code and this code functionally is a little bit, well, functionally is different, but the idea is still the same in that after this code executes, or after this code executes, and the invariant after this is that the invariant at this point is that SL contains left, right, probably inclusive, and every pair is between limit, right? The absolute abs difference between every pair is less than or equal to limit, right? So that's basically it. But now I'm going to erase one of these because this doesn't make sense. But for me, it seems like with this problem, this way is, what did I do? This way is cleaner, so I'm going to keep this one. But I just wanted to show you that that's why there's so many ways of doing it. And then they don't have to, you know, these are just a little bit preferences. I don't think that matters that much, right? And then now we can go, okay, now the contribution part, right, is that, okay, now this is true, and right is equal is the right index, right? It's the right boundary, right index, blah blah blah. And then now we can do max on that, and the length of that is just going to be right minus left plus 1. You can also probably do just the length of the side, the sorted list, and that's pretty much it. Yeah, watch I make a silly mistake somewhere, but that's basically the idea, you know, behind this problem. Did I do it in mono Q? Oh, I did do it with min Q, max Q. I think that back then, I don't know. I did do a video on min Q and max Q, so maybe that's why I did it that way back then. And here I did have a balanced binary search tree. Maybe I used this as an example to teach this. Wouldn't surprise me. But yeah, and this is also mono Q. But yeah, maybe today I'm a little bit lazier because apparently in the past I've always done it with mono Qs. But yeah, the only difference is that so the invariant is always good. You know, as long as you keep the invariant, it's going to be good. It's just having this adding and ensure invariance part. And here, this is the max minus the min inside the sorted list after we added this, right? Using a mono Q, you can also check that. The only difference is that this complexity is log n. This is log n as well. For each number, we add once and we subtract or remove it from the sorted list once. So this is going to be n log n just from this. And yeah, so this is going to be n log n time O of n space from the sorted list. And there we have it. If I have a video in the past, you could probably watch that video for the mono Q part. Keeping in mind though, people always give me a little bit of comments about my old videos, and I'm like, look, these videos are from 5 years ago. Stop commenting on them. I mean, they're there if you want to check it for reference. I'm not going to delete them, but like, you know, some stuff hopefully it gets better over time. I don't know. But anyway, that's all I have for this one. Let me know what you think. Send me your good luck for the contest. I don't care about my rating that much, but it's still nice and feels good to have a good contest once in a while. So yeah, stay good, stay healthy, to good mental health. Like, I'm thinking I'm like Goku or something, like send me all your power. But yeah, I'll see y'all later and take care. Bye bye.